Hey everyone, glad to see you again and glad to be back on stage here at stackconf. And on this talk, I would like to talk to you about the open source for better observability. And let's start with a little quiz. Okay. What's that?
My nightmare.
Your nightmare. It's a good answer. Any other guests? Yeah, I guess this is our story. So that's a very good answer. In fact, that's the architecture diagram for Amazon and Netflix, but it looks like the nightmare of your product and maybe many other products. And my question for you as a thinking process for today, what would you say it would take to monitor a monster like that? So keep that thought and that question in mind because we'll try and explore that on this talk. I'm the principal developer advocate at logs.io. At logs.io, for those who don't know, we provide the cloud-native observability platform that's based on popular open source stacks, so things such as OpenSearch, OpenTelemetry, Jaeger, Prometheus, and others. And as I was introduced, I'm also an advocate of open source and communities in general, and the CNCF, the Cloud Native Computing Foundation in particular. I co-organize the local CNCF chapter in Tel Aviv, DevOps Days Tel Aviv. I also have a podcast called Open Observability Talks. So if you're into open source, DevOps, observability, do check it out. And you can find me everywhere at Horovits. And let's go back to the thought exercise. And as you probably, but first agenda, I forgot about that. We'll talk about what observability really is, beyond the buzzword, the role of open source in observability, and also the challenges with open source in observability. We'll talk about the leading open source tools, projects, standards, and to finalize, I'll talk about OpenTelemetry and the vision for unified observability. And I put some interesting links for follow-up read. So if you're interested, do feel free to take screenshots. No problem about that. And back to our question. Monitoring cloud-native systems is hard. And why is that hard? It's hard because we're talking about highly distributed systems with hundreds and thousands of nodes and pods and the containers and the instances and what have you. Also highly dynamic systems. Things very ephemeral as well, things moving around, spinning up, tearing down, scaling in, scaling out. Also, we have many more things to monitor. It's not just the operating system in our app. Now we have the concepts of container, pod, namespace, deployment version. We need to monitor Kubernetes control plane itself, and so on. And we have many additional dimensions by which we want to slice and dice our data. We want to ask per pod, per node, and so on. So high cardinality, actually that was the topic of this month's episode in my podcast about high cardinality with the co-founder of Lightstep. So it is an issue, a known issue. And maybe the last point about the complexity here is the vast use of third parties. Every typical system these days uses for the API gateway, the message broker, the HTTP proxy, the graph database, the NoSQL database, whatever. Third parties, it could be open source projects, it could be cloud services, it could be closed source, whatever. And we didn't write them, but we need to monitor them. And this is a challenge with such a vast ecosystem, and it's so changing so rapidly. So that's why it's difficult, and you don't have to just take my word for it. When we asked people about their challenges running these systems in production, the top challenge has been, that's it from DevOps Pulse, whoever attended my talk yesterday heard more stats from there. Monitoring and troubleshooting is a top challenge for people to run in these environments in production. So it's hard, okay, and what we need for this monitoring is observability. In fact, when I went back to the very definition of cloud-native systems by the CNCF, the very definition talked about systems that are observable. And note this word, observable, as a property, inherent property of the system. Not something that you bolt on in the aftermath, but a property, something that is taken in the original design, something that is a first-level citizen. And bear that in mind for the rest of the talk. But what is observability anyway? And here's where everyone goes to the traditional definition borrowed from control theory, as you can see here. Observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. And when we talk about software systems, these external outputs are the telemetry that our system emits. Primarily logs, metrics, and traces. Some people call it the three pillars of observability, although I'm a bit against it. There are many other signals, like continuous profiling and snapshots and many others, but these are definitely main ones. And going back to observability for software systems, I actually prefer a different definition of observability, and I'll tell you why I prefer that. The definition is the capability to allow a human to ask and answer questions about its system based on the telemetry data. So the more questions we can ask and answer about our system, the more observable it is. And the reason I like this definition much better is that it makes it very clear that observability is essentially a data analytics problem. This is something that I've been advocating for quite some time, and it's very essential. I even wrote an article about it in Inside Big Data if you want to have a look. But why is that so essential? We'll see in this presentation. So now that we understand what's observability about and the three pillars, let's see how these three pillars help us understand the what, the why, and the where about our system. And let's start with metrics. That's usually the starting point for any incident investigation. And metrics tell us what happened in our system. They can tell us that a service went down. They can tell us that an endpoint is slow to respond. We had a fabulous story by Spotify. I see a cat here with how she investigated a major incident in Spotify. So that's usually the starting point. And metrics, in essence, is numerical data. Numerical data, which makes it also very easy to collect, to process, to store, to aggregate. But on the other side, it lacks context of what happened around that numerical data. So that's, and the way it works is that our systems emit these metrics, and then we have a backend that collects these metrics, aggregates them, stores them in a time series database, and exposes a query language that is designated for querying time series data. So that's in essence what we'd be looking for in our tools that I'll show you later. Bear that in mind. So that's metrics telling us the what, and then logs typically tell us the why things happened. And the reason that logs are so suitable for telling us why is that they're very verbose. They contain a lot of information. Essentially, the developer who wrote that piece of code sends out everything that happens in that code that he wrote. So it's very verbose, but then it's also pretty, it could be pretty expensive to store because it's very verbose. So it's sort of the flip side of metrics in that respect. And the way it works, again, from tooling, what we'll be looking for in tooling is the ability to pass incoming logs, to be able to index full text indexing, and then with storage and query language that is capable of querying this full text search and be able to query by any field that is hidden somewhere in this log line. So that's about logs. And if metrics tell us the what and logs tell us the why, then traces tell us the where. Now, traces are the least known, maybe signal in observability, so I'll dedicate a bit more time about that. And what do I mean by where? So in microservice systems, every request coming into the system flows through a chain of interconnecting microservices, right? And then I would like to ask a question like, where did the error occur? Or where did the slowdown, the latency come from that I experience in the endpoint? Or where is the critical path in my workflow? So these are the sorts of questions that distributed tracing come to answer. And the way that it works in terms of tooling, our systems emit for every call in that call chain, there is a span emitted. You can think of spans as a structured log in a way, but with context. And that context contains obviously the start time and the duration of that execution, the service, the operation, the parent span calling it, and many other types of information. That context is automatically propagated for you throughout the system, so you don't need to worry about it typically. And then these spans are emitted, and you have a backend collecting these spans, reconstructing the trace based on causality, who called who. I'm disconnected from the audio. Can you hear me? Okay, sorry. So the backend collects, reconstructs the traces, and then visualizes. That's a typical visualization, the timeline view that shows the sequence of calling, which were called after which, the duration, and so on. So that's how traces and tools work. Just to summarize, observability, in my definition, the capability to ask and answer questions, and metrics, logs, and traces help us with the what, the why, and the where. And now that we have that settled, we understand what observability is and the three pillars, let's talk about the role of open source in observability. And before I reach the tooling themselves, I want to share three important insights about the role of open source. First, open source is the new norm for observability. You see many analyst firms discussing that 60% of all open organizations use open source monitoring. Also, the most commonly adopted tools are open source. So wherever you go, you see open source is key to observability. And it's not surprising because the same open source community that brought us Kubernetes and the cloud-native ecosystem then brought the solutions for monitoring and managing them. So that's and important to say, it's not just tools, it's also standards. So standards such as OpenMetrics, OpenTracing, OpenTelemetry that could help converge the industry around open standards and avoid vendor lock-in. I'll touch about some of these later on. But there are also challenges in open source observability, and the first is the issue of tool sprawl. There's no consolidation in open source observability. This is from a very recent Cloud Native Observability microsurvey conducted by the CNCF, the Cloud Native Computing Foundation. And as you can see, more than 1 out of 4 use between 10 to 20 different tools for their observability. Between 10 to 20 tools. That's a lot. And another question they asked on the same survey, the greatest challenge with observability, the number one, engineers and teams using multiple tools. 50%, 1 out of 2, reported this challenge. So it is a pain, and it's a pain not just because of the need to manage many, many tools, or the operational side. It's a challenge for the very nature of observability, because, as we said, observability is a data analytics problem. And many tools create many data silos and make it much more difficult to ask and answer questions across your system. So this is one challenge. And another challenge that I want to mention is relicensing in that landscape. In the last year alone, we've been seeing several major announcements about relicensing popular open source tools, moving to more restrictive licenses, to copyleft licenses such as GNU AGPL, or to maybe to non-open source licenses such as SSPL. And that's obviously something that is impacting the industry. Typically, this happens by vendors owning the open source. I actually wrote an article. I don't know if you can see the bottom of the screen. Whoever wants to see, I wrote, is vendor-owned open source an oxymoron? If you want to check out this blog post. And what it means is that you may still have access to the source code, but you are restricted in what you can do in your usage and modification of that code. This obviously can be problematic and in some cases even necessitate that you need to open source your own code using it. And that puts obviously many users in a problematic situation and pushes many users to look for alternatives. It could be users that are themselves open source projects that they can't get this open source licensing imposed on them, and it could be commercial companies such as Google. I had the quote here from Google's open source policy forbidding AGPL, and in that article they actually said that the risk simply overweighs the benefit. So that's something that impacts the open source landscape in observability. So just to summarize, we saw that open source is key. However, we saw that there is a challenge of tool sprawl, and we saw the relicensing that is shuffling the map around observability. And now that we understand observability and the role of open source, let's talk about the tooling. Which tooling are the most popular for these for observability? And I'll go over them according to the three pillars that we talked about before. Funnily enough, there is a lot of confusion because many of them name themselves OpenX. So I actually wrote a little dictionary to help navigate around all these OpenX. If you want the link at the bottom, but I will touch about the main ones. Again, according to the pillars of observability. And the first one being the metrics. And Prometheus is by far the most popular tool there, especially for Kubernetes-based and for cloud-native-based deployments. Prometheus is under the CNCF. It's in fact the second project to have graduated from the CNCF after Kubernetes, and it has a native integration between them. And the nice thing about Prometheus is that it takes care of a big chunk of that stack, the functionality that we talked about before. So first of all, Prometheus offers us a service auto-discovery. So it can automatically detect all these components and microservices and the third-party infrastructure pieces in your architecture. It's called targets in Prometheus terms. And then it could do scraping, metric scraping off of these targets. So it reaches out to each and every one of the components, fetches the metrics in a pool mode using OpenMetrics. I'll touch about that. Then it has a time series database for storing that data, and exposes a query language called PromQL for querying that data in a very comfortable label-based querying. So Prometheus is highly popular, and I mentioned that it has native integration with Kubernetes, but also with many other tools and projects, both in the CNCF ecosystem and outside of it, and that's thanks to OpenMetrics. A word about OpenMetrics, that's an open standard that started as a part of Prometheus and spun off, so now it's an independent open source project under the CNCF that provides an exposition format. And many companies, tools, projects adopted that. So whatever you use, whether using Kafka or Mongo or MySQL or Nginx or Jira, GitHub, AWS ECS, Azure Health, whatever, you're more than likely to find out of the box that they expose metrics in this format. And that's a very essential part. We talked about the challenges of monitoring cloud-native systems. We talked about the large, vast ecosystem that you need to support. Having this standardization is crucial for handling this challenge. So that's great news. And the last open source I want to touch upon, it's Grafana by Grafana Labs. That's not part of the CNCF like OpenMetrics and Prometheus. And this is a visualization tool that has an excellent integration with Prometheus, and many like working with Prometheus and Grafana to visualize the metrics from Prometheus. One note about that from last year, that Grafana has been relicensed from Apache 2 open source license to AGPL version 3 open source. That's a copyleft license, an infectious license if you'd like. So it may shuffle the map and the adoption. So maybe next year when we talk, it will look different, but definitely something to be aware of when going over that. So that was metrics, and now let's talk about logs. And for log analytics and management, for many, many years, Elasticsearch has been highly popular. It's a distributed text storage with that's based on Apache Lucene search, textual search. It's also exposes Lucene query syntax, and it comes bundled typically with Kibana, which is a visualization tool, and with Logstash, that's the pipeline ingestion. One note about that, from last year, both Elasticsearch and Kibana have been relicensed from Apache 2 to SSPL, that's a non-open source license. So technically it's not open source. The reason I left it here on the slide is first because many still use the versions from before the relicensing, version 7 and older, so these are still Apache 2. And also many are still not aware about, of this licensing, so it's important to note. And what the community has done in response to the relicensing is it forked Elasticsearch and Kibana and created OpenSearch. It's a new project that is Apache 2.0, aimed to keep Elasticsearch and Kibana open source, and also now it has its own roadmap in observability. It's backed by AWS primarily, and also my company Logs.io and many others, Percona that were here in the conference earlier. Pretty interesting alternative if you're looking for that, although young. And the last open source I would like to mention is Loki. Loki is a bit of a different animal in that respect. It doesn't do full text indexing and search and parsing. It actually groups by the same labels that you use in your Prometheus. So it's obviously much more efficient to scale and has better native integration with your metrics. However, much more limited search because it's not full text search. So, and an update on that, same as Grafana, Loki has been relicensed by Grafana Labs to AGPL copyleft license last year. So that's logs, and for traces, that's the youngest one. So the youngest ecosystem, the leading open source is Jaeger Tracing. That's a project under the CNCF. Other projects, Zipkin and Skywalking, but Jaeger is definitely the leading choice here. I want to make an important note about just having logs, metrics, and traces is not enough to gain observability. And the reason is, as I mentioned quite a few times, that observability is a data analytics problem. So I'd like to go over very quickly about 3 problems that I keep seeing and see how we can fix them to make sure that we have good observability. First one is work with logs that I still see, flat files with textual unstructured logs. This is obviously not geared towards data analytics and machine processing and so on. So we need to move to a structured way of working with logs, machine readable like JSON and so on, enrich with metadata to enable correlation between logs and metrics and traces like the trace ID and things like that. That's one tip. The other tip is, again, I see logs, metrics, and traces, but the mindset is like a sysadmin reactive mindset, and we need to move to thinking like data analysts. We need to proactively query the data and understand what's going on. And the last bit, again, having logs, metrics, and traces, but as 3 silos. And as we said, being data, observability is a data analytics problems means that we need to fuse all of this data together to be able to ask and answer questions across our system. And now that we covered that, the last bit that I want to say is about the challenge. Remember that at the beginning of the slide, I showed you how many, the tool sprawl, people using between 10 and 20 different tools for their observability. So, and each tool and each vendor has its own agents and the SDKs for generating the logs, metrics, traces, and then their own daemon, collector, whatever, to collect that, and their own data model for transmitting that. And that is a problem when we talk about, again, the challenge of such a vast ecosystem. So the question is, how do we generate and capture data in a uniform manner? And this is what OpenTelemetry project comes to solve. OpenTelemetry is a project under the CNCF, and it is a framework for generating and capturing telemetry data across traces, metrics, and logs, and potentially more signals to come ahead. So one system to rule them all, if you'd like. It's a merge of OpenTracing and OpenSenses, if you're familiar with that, and it comes to solve this exact problem. What OpenTelemetry provides us is a set of APIs, SDKs, and tools, and mainly standards for generating telemetry, logs, metrics, traces from our application, whichever language, programming language you have. Then a standard way of collecting that telemetry from your application or from other infrastructure elements like your Kafka, your MySQL, your AWS services or whatever, and then sending them in a standard format to whichever backend you like. So OpenTelemetry doesn't care about the backend. You want to use Prometheus, you want to use Datadog, you want to use Logs.io, or whichever, it doesn't really care. So that's OpenTelemetry in an essence. And with that, let's summarize what we've seen. We've seen that monitoring microservices and cloud-native systems is hard, and we need observability. We also saw that observability, open source is the new norm for observability. Projects such as Prometheus and Jaeger and OpenTelemetry are becoming the de facto standard. I forgot to mention OpenTelemetry today is the second most active project in the CNCF. So second only after Kubernetes itself, so highly active project. We also saw that we have challenges. We have tool sprawl, lots of tools in observability space, and also the challenge of relicensing that changes the map. Most importantly, we saw that we need to that they create data silos, and we need to bring them all together, fuse them together, and create this full observability. Be able to ask and answer questions about a system. That's essentially what observability is about. And we saw that open standards such as OpenTelemetry and OpenMetrics and so on are converging the industry and helping to avoid the vendor lock-in. So this is in summary, and maybe if there's one thing that I want you to take out of this talk is, and I said it many times, observability is a data analytics problem. So treat it as such, and it will get many things in order for you, and that open source is key, and it definitely provides the good path to check it out. And we have time for questions. I also promised you the resources, so if you didn't have time, you can take a picture while we have the Q&A, and I'd be glad to take a few questions as time permits.